this problem we're looking at limits as x goes to infinity or x goes to negative infinity. So we'll start it off with the function f of x equals the cosine of 1 over x, and we want to use tables and graphs to estimate the limit. So as x goes to infinity, we're considering values of x that are extremely large. So we're going to plug in some values and make them increasingly bigger. So plugging in 10 and the output was 0.995, plug in 100, 1,000, 10,000, and keep putting in larger and larger values. And notice that what happens is we're getting to the point where the answer is always 1. What's really happening is it's 0.99999 with more nines than the computer could handle, so it rounds up to 1. So as x is getting very, very large, the value of the function is approaching 1. Graphically, we see this as x goes to infinity, 1 over x gets closer and closer to 0. So what we're evaluating is approximately the cosine of 0, which is equal to 1. So we have a graph that's settling on and then running along the constant function y equals 1. As x goes to negative infinity, we're considering values of x that are extremely small, or if you prefer, very large negative numbers. So again, plugging in some values, we have negative 10, negative 100, negative 1,000, negative 10,000, etc. So as the numbers get smaller and smaller and smaller, the value of the limit approaches 1 again. As x goes to negative infinity, 1 over x gets closer and closer to 0. It's negative, but it's still very close to 0, so our result should still be approximately the cosine of 0, which is equal to 1. And looking at this graph, we can see as x is heading off into the negative infinity direction, the value of the function is settling close to the line y equals 1. So, for part A, the limit as x goes to infinity of f of x equaled 1. For part B, the limit as x goes to negative infinity of f of x was also equal to 1. That means that y equals 1 is our horizontal asymptote, because both limits are the same in either direction.